Well, hello everyone. Today we are going to present our ETC project on automata-based lexical analyzer and parser for mini ATC language. This project is based on concepts of automata theory and compiler design. Our team members are Adil Malik, Nafizullah, Abhishek Yar, Grishma. Under the guidance of Mrs. Mukta, PVL coordinator. ಇದು ಕಟ್ ಮಾಡು.
ಮಾಡು ಮುಂದೆ.
Automata theory is one of the important subjects in computer science. It plays a major role in compiler construction, syntax checking, and programming language processing. In our project, we implemented a lexical analyzer and parser for a simple programming language called Mini ATC. The project demonstrates how finite automata and context-free grammar are applied in real applied design. The lexical analyzer identifies tokens from source code, while the parser checks whether the program syntax is correct or not. This project helps us understand the practical implementation of theoretical concepts learned in automata theory. Objectives. The main objectives of this project is to understand the practical implementation of the automata theory concepts. We objectives to understand lexical analysis and parsing concept, to design for identifier recognition, to identify keywords, identifiers, operators, delimiters, and numbers, to implement a lexical analyzer using Python, to parser using CGF rules to verify whether the mini ATC program is synthetically correct. These objectives helps us to connect theory with practical programming implementation. Next will be done by Grishma.
Next will be continued by Adil. Ilu ಇವನು ನಫೀಸ್.
It is continued by Nafiz.
ನಫೀಸ್ ಮಾಡು.
Hello everyone. Hello everyone. I'm Latif. I would like to explain the problem statement of this project. The problem statement of this project is to design and implement a lexical analyzer and parser for the ATC programming language using automata theory concepts. The lexical analyzer should identify tokens such as keywords, identifiers, numbers, operators, delimiters. After token generation, the parser verifies whether the given mini ATC program follows correct grammar rules using context-free grammar. Finally, the system displays whether the program syntax is valid or invalid. The main goal is to simulate the basic working process of a compiler. The next is DFA. In this project, we designed a DFA which stands for Deterministic Finite Automation for Identifier Recognition. The DFA work as follows. Q0 is the starting state and Q1 is the accepting or final state. If the identifier starts with a letter, it moves from Q0 to Q1. After reaching Q1, it can continue accepting letters or digits. Example of valid identifiers are like total 1, sum 2. If the identifier starts with a digit or symbol, it becomes invalid. This DFA helps in validating identifiers during lexical analysis. The next is invalid identifiers. Examples of invalid identifiers are 1x, AB minus C, A is not equal to B. These identifiers are invalid because identifiers should not start with digits or contain special symbols. Using DFA, the lexical analyzer can easily verify whether an identifier is valid or not. This improves syntax checking during compilation. The next slide will be continued by Abhishek. Grish.
Hello everyone, I am Grishma and I am explaining about code explanation. In this slide, we explain how the program is written and how it works. Our project is developed using the Python programming language. The code mainly have two parts, lexical analyzer and parser. Lexical analyzer. The lexical analyzer is the first phase of the compiler. Its job is to read the mini ATC program line by line and break the program into small meaningful units called tokens. These tokens The compiler understands the program. Types of tokens identified. The lexical analyzer identifies different types of tokens such as keywords, special reserved words in the language. For example, begin, end, int, print. Identifiers. Name given by the programmer. For example, X, total, someone. Numbers. Numeric value used in the program. For example, 10, 25, 100. And operators. Symbols used for the operations. Example is equal to de- delimiters. Symbols used to separate statements. For example, semicolon, commas, or brackets. Regular expression. The lexical analyzer uses regular expressions to identify tokens. Regular expressions are patterns used to match text. For example, begin for keyword, X for identifier, 10 for number, is equal to for operator. Tokenization. The program of converting the source code into tokens is called tokenization. For example, input X is equal to 10, semicolon. Output taken, identifier X, operator is equal to number 10, and delimiter is semicolon. This makes the program easier for the person to analyze. The next slide is personal explanation or simple explanation. After tokenization, the tokens are sent to the parser. The parser is successfully phase of the compiler. Its main job is to check whether the program follows the grammar rules of the mini ATC language. What is the parser check? The parser verifies whether program starts with begin. Every mini ATC program must start with the keyword begin. Program ends with end. Every mini ATC program must end with end. Then statements follow correct syntax. The person checks whether all the statements are written correctly. For example, x is equal to 10, semicolon. This is the correct because identifier is present, assignment operator is present, value is present, and even semicolon is also present. Correct program example is begin int x semicolon, x is equal to 10 semicolon, print of x semicolon, and end. If all rules are correct, the parser displays program syntax is correct. If the program is incorrect, the parser will display syntax is error. Context free grammar CFG. The person uses CFG rules. CFG defines how statements should be written in the programming language. This grammar rules helps the phraser identify whether the program structure is valid or invalid. Then final purpose of using these two both types are the phrases helps detect syntax mistake before program execution. This improves program correctness and reduce errors. Next slide is continued by Abhishek.
Hello, myself Abhishek here. I am going to explain the execution of the program. To execute the program, we used the following command: Python 3 main.py. Example input program: begin int x semicolon, x is equal to 10 semicolon, print x semicolon, end. The lexical analyzer generates tokens such as keyword, identifier, operator, number. These generated tokens are then passed to the parser for syntax verification. Output: for the valid program, the final output is program syntax is correct. We also tested invalid programs. For example, begin int x is equal to 10 semicolon end. In this example, a semicolon is missing, so the parser detects the mistake and displays a syntax error. This shows that the parser successfully validates program syntax. Conclusion: in conclusion, this project helped us understand the practical application of automata theory in compiler design. Through this assignment, we learned DFA design, lexical analysis, token generation, context free grammar, parsing and syntax validation. The lexical analyzer successfully identified all tokens and the parser verified whether the mini ATC program was grammatically correct. This project improved our understanding of compiler construction, concepts, and programming language processing. Thank you.
Katma Dusak.